Hello, welcome back to Bioclass Bites. In this video, we are going to talk about natural hazards and calculating disaster risks. Don't forget to subscribe to my channel and like and share this video. In the first two videos of this series, we have thoroughly defined what disaster and disaster risks are. So just to review, a disaster is a serious disruption of the functioning of a community or society. This usually involves human, material, economic, and environmental losses, and the impacts exceeds the ability of the community to cope using its own resources. So that's how we define disaster. Okay. Hazard, on the other hand, it is a dangerous phenomenon, substance or human activity that may cause loss of life, injury, or other health impacts, property damage or loss of livelihoods and services, and social and economic disruption or even environmental damage. So we mentioned in the last video that the natural hazards will always be there. Okay? The natural hazards such as earthquake, environmental phenomenon, ecological events, they will always be there. The only thing that will turn a hazard into a disaster is when we failed. When humans failed to make adaptation and mitigation measures against it. Okay, that's why if you still remember, we've talked about vulnerability and exposure. So if we lessen the vulnerability of a community, or we lessen their exposure to that particular hazard, then the disaster risk will not be as huge. Okay, will not be as tremendous. So there are two types of hazards. The first one are natural hazards. So as the name implies, these are naturally occurring physical phenomenon. Okay? While man-made or technological hazards, they originate from technological or industrial conditions. Okay, so man-made, um, including accidents, dangerous procedures, infrastructure failures, or other specific human activities. According to the World Meteorological Organization, they define natural hazards as severe and extreme weather and climate events. Okay, they occur in all parts of the world, but some regions are more vulnerable than others. Okay, we've talked about this discrepancy in vulnerability, and natural hazards will become disasters when people's lives and livelihoods are destroyed. Okay, you can check out this page from WMO. I'll provide the link in the description below. Now, from Zurich, they say that natural hazards impact the impact and likelihood of natural hazards increases often due to man-made behaviors. Okay, so across the globe we have windstorms, wildfires, earthquake, floods, and others. So that's the reason why we need to be aware of our exposure. There's that word again. Exposure to natural hazards and take action to mitigate or to lessen the disaster risks. So we will look into some of the common natural hazards. So the first one would be hurricanes, typhoons, and tropical cyclones. Um, so these are all weather phenomenon. Okay, these are destructive natural hazards. But what are the differences between these three? Actually, they are just the same weather phenomenon. They are just called differently based on their location, on where they occur. So generally, these are tropical storms with the speeds exceeding 119 kilometers per hour. Okay, so that's quite overwhelming. Okay, so in North Atlantic Ocean and North Pacific, they call that hurricane. Typhoon for Northwest Pacific Ocean, and a tropical cyclone for in the South Pacific and Indian Ocean. Okay, so they just refer to the same tropical storm exceeding 119 kilometers per hour. They are just called differently on the different parts of the globe. Another thing that we should know about would be the difference between tornadoes and tropical storms. So if that If that storm occurs on land, we call it tornado. If that storm occurs over bodies of water, over tropical oceans and seas, then we call it tropical storm. Okay, so they're just the same. If the storm occurs on land, tornado. If the storm occurs over bodies of water or oceans, storm, tropical storm. Um, in terms of life cycle, tornadoes are generally shorter, while tropical storms can last from days up to weeks. Okay. Annual occurrence, there are around 800 to 1,000 tornadoes in the U.S. Annually. Then 10 tropical storms in the North Atlantic Ocean, and there's more here in the Philippines. Advanced weather warning, no more than 15 to 30 minutes, while tropical storms can be predicted or the public can be notified of an oncoming tropical storm several days before it lands. Okay. Another common natural hazard here in the Philippines would be flood and water damage. So, still from Zurich, flooding affects more people globally than any other natural hazard. Water damage is one of the most common and costly insurance claims. And especially here in the Philippines, we are always under flood risk. Okay. So these are common types of flood. So the first one will be fluvial floods. So that refers to overflowing of a river, usually a river or a lake. So overflowing of the river and then they go into the community. Um, Pluvial floods, letter P, pluvial floods. Um, it happens due to extreme rainfall, okay, in a community. So even if they are not near a river or not near any body of water, if there's an extreme heavy rainfall, then flooding could occur. Flash flooding, okay, is another type of flood, okay, and then coastal flood or storm surge, okay, so brought about by sea, okay, going into the shore, so that's another type of flood, okay. So again, flash flooding also caused by extreme rainfall. So let's go deeper, no? So pluvial floods, so we've mentioned these are also known as river floods. So the flooding of a community or on an area happens due to the overflowing of a river or lake. Okay, so they overflow and then they go into the surrounding banks or surrounding shore or neighboring land. Okay, so this could be due to excessive rain or snow melt. Okay, so in our case, excessive rain. The damage from a river flood can be widespread as the overflow affects smaller rivers downstream. Okay, so here we see this one was taken satellite image of the Fitzroy River. Um, so from Italian Space Agency. So before the floods, so this is how the river usually looks. But because of pluvial floods or overflowing of this river, as you can see, so these regions were heavily flooded. Okay, so this is from Italian Space Agency, but this occurred in Australia. Pluvial floods, these are your flash floods and surface water. So again, this is because of heavy rainfall. So this occurs when an extreme rainfall event creates a flood, even if they are away from a body of water. Okay, so they can happen at any location, urban, rural, even if there's no bodies of water around. Okay, so flash flood or pluvial floods. Then coastal flood or storm surge, this happens. This is the inundation of land areas, okay, along the coast by seawater. So, um, if there's a very strong tropical cyclone, it could affect the waves, and then eventually the storm surge, the seawater could go into the shore and then affect the communities there. Okay, so it is created when high winds from a windstorm force the water on shore. Okay. So, if you are interested with seeing deadly tornadoes, so this is from from Spark. mega disaster, the world's deadliest tornadoes. You can watch this and I'll provide the link in the description below. The next major type of natural hazard would be earthquakes and tsunamis. Okay? Unlike hurricanes and other natural hazards, earthquakes strike suddenly and without warning. They can even trigger tsunamis if they occurred underwater or under the sea. And now there's this global move towards ensuring that buildings and infrastructure are earthquake ready and can reduce the risk damage brought about by earthquakes. So, if you want to refresh your memory, I hope you still remember your lesson from grade 11, Earth and Life Science, the movement of plates, okay, the plate tectonics and how they actually trigger earthquakes. So, I hope you still remember your lesson from then. But if you're interested, you can check this out from National Geographic, Earthquakes 101. I'll provide the link in the description below. This one also, earthquake magnitude versus intensity. So the difference between these two modes of measuring earthquake. I'll provide the link in the description below. So these are the two scales known to measure earthquakes. So the first one is the Richter magnitude scale. So what's being measured here is the amount of seismic energy released by an earthquake. Okay, so Richter magnitude, it measures the energy of the earthquake. So there's base to 10 logarithmic scale. So those that are below, below low magnitudes, the earthquakes are not felt but recorded by some sensitive instruments. But for those 4, 5, 6, they can be noticed by humans on the surface. Okay, 7, 8, 9, they can cause serious damage, even cause loss of lives and devastate areas and thousands of miles across. And then we never had a recorded 10 plus magnitude earthquake. Okay, so they call it an epic earthquake. Okay. So again, Richter magnitude, what's being measured here would be the energy released by an earthquake. The modified Mercalli intensity scale, okay, it measures how it is felt by the people on top, okay, on top. That's what they're measuring. So how is it felt by the humans, okay? So we have 1 to 12, okay? So category 1 to 12. So 1, 2, 3, 4 felt by a few people, light vibration, generally noticed indoors. But 5, 6, 7, they are the ones that are felt mostly by everyone. It can wake up several people and alarm people. People can experience difficulty in standing for MM7. Furniture and appliances can shift. Then MM9, 8, 9, 10, this could actually damage buildings and infrastructure, especially the weak buildings. And then completely devastating all buildings, and most all buildings are damaged and most buildings are destroyed. Now this table shows us the frequency of earthquakes based on magnitude. So so for magnitude of 2 2 3, we have every year we can have between 1.3 million um, earthquake earthquakes of that magnitude in a year. However, no, these are rarely felt by humans and there's no property damage. So 1.3 minor earthquakes in a year. And the energy release is just 1,800 equivalent kilograms of an explosive. So it's quite common. But for those um, between moderate earthquakes that can damage properties, especially to poorly constructed buildings. So we have annually 1,300 plus of that. So that's an equal of 56 million kilograms of explosive. That's the energy release of that earthquake. Then very few for those very high magnitude earthquakes. Less than only one for a great earthquake, for example, the Sumatra earthquake or the Mexico City earthquake. And then less than one, largest recorded earthquake in Chile, Alaska, and Japan. So this is quite uncommon. Okay, while we have a total of almost a million 1.3 million minor earthquakes annually. Now, I hope no, you will again. I hope you still remember your lessons from grade 11 Earth and Life Science. Okay, but to refresh your memory, this video from Vox will answer the question why there's a ring of natural disasters around the Pacific. So that's where our country, the Philippines, is found. So if you're interested to review yourself, I'll provide the link in the description below. Now this one is from Iris. .edu. This one is a seismic monitor and a real-time seismic monitor. If you're interested, you can check the link, check the link, and then it will bring you to this application, web application, and then you can check this out. Okay, again, linked in the description below. Now there are several factors that we have to be observant about. Okay, when earthquakes occur. So one thing would be the difference of the damage of an earthquake based on the construction materials of a building. So as you can see here, this one was um, a five-story JCPenney building in Anchorage, Alaska. So this after an earthquake, this building most probably um, only using light materials was heavily damaged, while this other building here, which is quite lower, no, it only has 2 stories, no, remained intact after the earthquake. So another thing that can actually determine the damage of an earthquake would be the type of materials used for the building. So the more sturdy the materials are, the more they can withstand earthquake. But the lighter the materials are, then they cannot withstand the earthquake. Another thing would be the aftermath of an earthquake. Okay, so fire is actually commonly triggered when an earthquake happens, mostly due to a gas line rupturing during an earthquake. So if a gas line underground ruptures, that can trigger an earthquake. Okay, so for example here, so this one is the 1994 Northridge earthquake in Southern California, and then this one is the 1906 San Francisco quake. Okay, where a fire followed the earthquake, but because of the broken water um, water system under the ground, they got broken because of the earthquake. The firefighters were not able um, put out the fire. Okay, which so aside from the earthquake, they had the fire, so it increased the damage of that earthquake. Another effect of earthquakes would be tsunamis. So if the earthquake occurred on land, so this is what we are expecting, okay? But if the earthquake occurred on the seafloor, okay, so as we all know, we have plates, oceanic and continental plates. So if the earthquake happens here, then the energy released from that earthquake could travel on the water or through the water and can reach the land. Okay, so for example, here we see this tsunami. Okay, tsunami generated by an earthquake in Sumatra in 2004. So actually, one of the first things that you should watch out for example, if you're out in the beach and then the water suddenly receded, it went, for example, it went back this way. So that's actually a cue for you to run uphill because it means that a tsunami is on its way. Okay? Except when you're there during low tide, no? So it's different. So if it's low tide, it's expected that the the water will be there at, farther into the horizon. Then as the tides increases, they become nearer. But if this happens suddenly, if there's this sudden receding of water, for example, when you're at the beach, so it means that there's a possible tsunami oncoming. So that's a sign for you, a signal for you to run uphill because there's a possible tsunami coming. So this one is an example of how a tsunami could devastate a community. This happened after the 2011 Japan earthquake. So this was the 2011 Japan tsunami, specifically the Natori city. So again, no, when an earthquake occurs beneath the sea, part of the sea floor rises or fall, water can be displaced, it can form a wave, then that wave travels and can reach the land. Okay? Energy release, the energy travels through water, it displaces water, and then it can reach the shore. So this one was still the 2011 Tohoku earthquake in Japan. So the epicenter was in Tokyo. So here, um, as you can see, after an hour later, the energy from that earthquake traveled through water. So after 3 hours, still traveling. After 6 hours, it reached somewhere in Hawaii. 9 hours, 12 hours on this side of the United States. They were able to feel the tsunami from an earthquake as far as Japan, because that's how much water was displaced, and that's how the tsunami was generated. Okay. So this one is still from the 2011 Japan earthquake, which generated the Japan tsunami. This is from National Geographic. If you're interested to watch, I'll provide the link in the description below. So we've mentioned that the Philippines is actually quite prone to natural hazards, okay? Because of our geographical location, and we are found near the Pacific Ring of Fire, and physical environment, we are an archipelago. So and then we are also prone to destructive cyclones in the Pacific. So all of this situation greatly affects our lives and even our properties, and also our economy. Okay, so phenomena that are atmospheric or meteorological or oceanographic and geographical in nature can eventually cause, and it already has caused, the loss of life or injury and property damage. Geologic hazards, okay, such as earthquakes, are also irregular events. Um, so an important characteristic of many geological hazards is that they have a prime land preference. So they mostly occur on land, and the Philippines is actually prone to those geologic hazards. Okay, so we thankfully no, we do not have snow, we do not have glaciers or seasonal snowfall. So at least we do not have that, but we are quite prone to volcanic eruptions, earthquakes, and landslides, even tsunamis and faulting. So if you're interested about other natural disasters, this one is from a playlist from National Geographic channel. So if you want to watch, I'll provide the link in the description below. This one, The Power of Nature, a playlist from TED about different natural hazards. So I also recommend that you watch this video. Again, linked in the description below. Now let's go to calculating or predicting disaster risk. I hope you still remember that we viewed a similar diagram, okay? A diagram similar to this, wherein the natural hazards will always be there, but what we have to do would be to lessen the exposure, or to move the community away, okay? To lessen their exposure, to relocate them, and then to lessen their vulnerability from that hazard. Okay. So this one is the World Risk Index for 2020. Okay. So, so as you can see here, the ones that are in green, they have quite high adaptation and coping abilities to disaster risks. Okay, so those who are in green, so the darker the green, the higher their adaptations, and then the higher their coping abilities. The ones that are in pink and then darker pink, they are the ones with lesser adaptation and coping abilities against disaster. So as you can see, most of those countries along the tropical region, okay, are the ones that are quite prone to disaster risk, while those that are above and below the tropical region are the ones that are mostly unaffected, or they are the ones who are capable of adapting or coping against the disaster risk. Um, so there are several factors that comes into play, okay, that allow this generalization to be formed. So first would be exposure. Exposure to disaster risks. So those that are in dark pink, they have quite high exposure to natural hazards. As you can see here, the Philippines. So we are in the Pacific Ring of Fire. We are near the Pacific Ocean. We are an archipelago, so we have a lot of disaster. We have a lot of natural hazards. Another thing would be susceptibility. They are dependent on infrastructure, nutrition, income, and general economic framework. So mostly those are still those countries. Okay? Next, vulnerability. Some of susceptibility, lack of coping capacities, and lack of adaptive capacities. So mostly still those countries. The Philippines, we never left the color pink. Okay? Lack of coping capacities dependent on government, medical care, and material security. Mostly again, still those countries. So all of this exposure, susceptibility, vulnerability, and lack of coping capacities makes it possible to calculate the disaster risk of a specific country. Okay, all of those factors come into play, and those countries that we have identified. So our country here, okay, we have such high exposure, such high vulnerability, but low coping capacities. Now, if you're interested to know how exposed is your barangay to different natural hazards, I recommend that you visit this page. I'll provide the link in the description below. This one, from this point onwards, no, most of the tables and graphs that I will show you will come from Our World in Data, specifically their natural disasters series by Hannah Ritchie and Max Roser. You can check this out. I'll provide the link in the description below. So this graph shows us the global deaths from natural disasters from 1900 to 2000. So those are natural disasters such as drought, floods, extreme weather, temperature, landslides, whatever, and all those other natural hazards. So from 1900s, 1920, there's this rise in global deaths, okay, 1930s, 1940s, 1960s, but 1980s and beyond, okay, as you can see, we do not have that much devastating number of global deaths from natural disasters. So one possible inference here would be after encountering all these disasters, our societies were able to come up with disaster mitigation procedures and disaster adaptation protocols that allowed us to have lesser number of deaths from natural disasters. Now, this graph shows us the sources of those deaths from different natural disasters. So, from 1900s and then 1920s, 1940s, the major causes of deaths would be drought, okay, some earthquake, and then very few from storm. Okay, 1960s and 1980s also, most of the deaths came from due to drought. But for 2000 and then 2010, mostly earthquake, storm, and extreme temperature. Very few for flood. Okay, so there's this shift in global annual deaths by natural disasters from drought to earthquake and extreme temperature and storm. Then I forgot, we also have here flood in 1930s, then 1950s. So again, we can infer that we have developed. So these were the identified causes of death, drought, and flooding. So perhaps during this time, we have developed mitigating procedures and adaptation procedures that allowed us to protect ourselves against such natural disasters. So other disasters were the ones who caused those natural deaths. This one also, so from 1900s to 1940s, major cause of death would be droughts. Then 1930s to 1960s, flood. And then after that, 1980s onwards, very few causes of deaths, mostly due to earthquakes. So no more about floods and no more about droughts. So we have learned to adapt to those. So this is a historical evidence that humans can actually adapt to those natural disasters. So now we're facing other disasters. But the number of global deaths have dramatically decreased over time. Now, this one are the number of recorded natural disasters events from 1900s to 2009. So, as you can see, there's this decrease in the number of reported um, natural disaster events. Now, one possible explanation would be, of course, with the rise of technology, with the rise of mass media, with the rise of television and internet, it made it more possible. It made it possible to report natural disasters to a greater number of people. So, this one are just the recorded, but it does not mean that these are only the number of natural disasters that occurred during this period. These are the ones that were just recorded. Now on here we have this rise in the number of reported cases or reported events. Well, because people are, they have better access now to internet, to mass media, to reporters, to television. So the natural disasters are being reported. Okay, so it's being brought to the attention of more people, and I think in a way or two that's it's quite beneficial because it allows people to send help to those countries that that need their help because the disaster was reported. Now, this map shows us the number of displaced persons. So they were the ones who were removed or who were obliged to flee their homes because of a disaster, natural disaster. So as of 2017, so we have quite many here in China, in India, here even in the Philippines, major parts of the U.S., Alaska. So those countries, they have quite a large number of people who fled their homes because of natural disasters. Now, this map shows us the score of adoption and implementation of natural strategies in line with the Sendai framework. So that Sendai framework of disaster risk reduction 2015 to 2030, that was an agreement by major countries, okay, that happened in 2015, okay, that wherein they created this procedure, all these agreements that will help one another on what to do to avoid disaster risk. Okay, so this is 0 to 1. So 1 being the highest, so that's almost 100%. So the countries with adoption and implementation of the Sendai framework are those that are in green. Okay, so Japan, of course. Um, Other parts of Western Europe, okay, European countries, some parts of Africa, some parts of South America, okay. So they have these national strategies in line with the Sendai Framework Agreement. Now, this map shows us the adoption of legislative or regulatory provisions for managing disaster risk. So these are the within their countries, okay, in line with the Sendai framework. So these are the ones who agree to the Sendai framework. That they will have their own national strategies. Then as of 2000, which happened in 2015, now as of 2018, so these are those countries that they have their own legislative, they have their own laws or provisions for disaster risk. So as you can see, very some countries um, um, scored lower than in within 3 years. So they have here in um, 2015, but then after 3 years, no, not all of those agreements were converted into national laws. Now, after that, these are the countries which implemented those disaster risk reduction strategies. So they said yes to Sendai. Then these are the countries that had laws to implement the Sendai framework. But then these are the countries with DRRM strategies. So there's there's a lessening in the number of those countries who are actively um, doing their part of the bargain or part of their agreement to the Sendai framework. Now we will learn more about the Sendai framework and the Yoga framework in in the next unit. So that will be the topic for those upcoming units. So we can discuss more of those things. So the Philippines, 2015, we do not have much data. Still no data for 2018. Okay, then we do not have implementing disaster risk reduction strategies. Now, if you're interested, I recommend that you read these resources. Okay, all of these are related to our lesson on disaster readiness, and risk reduction management. You can check this out from the online library. So, okay, you have the link there. Now, these are the tasks, okay, that I've given you to work on. So the first one would be analysis and essay on why Vanuatu is the world's most at-risk country for natural hazards. Then this one is an activity on building resonance. So you have to watch these 3 videos and answer the questions that follow. And then this one is a film viewing and activity. The year the Earth went wild from natural disasters. So if you want to watch, I'll provide the link in the description below. That ends our video. I hope you learned something new. Don't forget to subscribe to my channel and like and share this video. Till next time, goodbye.